Hello, this is Dr. Mears. Today we are going to be learning about the t-test, in which we are going to be comparing means. The mean is the average of a data set. A t-test helps us to compare two data sets that measure the same thing. We will test if the means of the data sets are the same, different, if one is greater than the other, or if one is less than the other. So if they're the same, they will be equal. If they're different, they will be not equal to. If one is greater than the other, there is your greater than symbol. If one is less than the other, there is the less than symbol. We will use the same null hypothesis, that's going to be our H sub 0, but we will have three different H sub A's. And I'm going to show you that in a little bit. All right, so let's first do an example of two-tailed test. In a two-tailed test, we're going to be testing if they're the same or if they're different. So let's see what that looks like. Dr. W gives his two chemistry groups, the same test. He wants to find out if there is any difference between the achievement levels of the two groups. Here we have core 1, here we have core 2. I just want you to notice that we do have more people in core 1 than we do core 2, and that's okay. You don't have to have an equal number of people in each core. Absolutely fine. You can have more in one than the other. All right, let's go through our steps. First, we're going to have to state what X bar 1 and X bar 2 represent. So when we do this, I hit the desk. Our X bar 1, I am going to label this core 1 as our L1, which is going to be our X sub 1. So that's our first X. So X sub 1, this is going to be the mean score of core 1. So if I added all of these core 1 scores up and divided by how many I have, that would be the mean score. This is going to be my L2 when I put it in the calculator, therefore that's going to be my X2, making it X bar 2, and that'll be the mean score of core 2. You always need to do this. I need to know what is 1 and what is 2. I know they're very self-explanatory here because I did make it core 1 and core 2, which does go nicely with X bar 1 and X bar 2, but in our examples you're going to see that it may be different. So always you want to state what they represent. It just helps you show that you understand the problem better. All right, let's write our null and our alternative hypotheses. Our null hypotheses is always going to be the same thing. So here we're going to use the same null hypotheses. And that's going to be where X bar 1 is going to be equal to X bar 2. That's always going to be true. That will never change ever. Okay? Now, for our alternative, we want to see if there's any difference. So we want to see if they are different. So that's going to be our not equals to. So here we have X bar 1 is not equal to X bar 2. Now, the reason why it's called two tails, and there are a couple different reasons. I'm not going to go in depth with those reasons. I'm just going to say it's two-tailed because we're not sure if, let's say that this is going to be the mean, X bar. We don't know if it's going to be less than the mean, and we don't know if it's going to be greater than. So we can have two different answers. It's a two-tailed. We don't know. We just want to know, it's going to be different? Is it going to be different? We don't care about if it's less. We don't care about if it's greater. We just want to know, is there a difference? So that's why it's called two tails, because it could be less or it could be greater. There's two other alternatives here, but we're just testing if it's different. Now, there is a whole graph that goes along with this. If you are in AP Statistics or a statistics class in college, you will be talking about this distribution, this t-distribution, where this is going to be your mu. And there is my phone, and my phone's going to be ringing. Step 2, calculate the test statistics using your graphical display calculator. First, we're going to be entering the data. So we're going to take our calculator out. Hopefully you don't hear that ring too much. And we're going to be turning it on. we need to enter the data. So you know how to enter the data. You're going to be pressing your Stat button, and then you're going to be pressing Edit. Now, in here, you're going to be putting your L1. Notice it is already in here just to save us time. So L1 is core 1 and L2 is core 2. So please put your data in, pause the video, and then you may come back. So again, that was Stat, and then we just went to Edit. Now that you have your data in, we need to run the test. So our second thing is running this test. So we have our data in, and we're going to be pressing the Stat button, which is right here, pressing Stat. We need to over arrow to test, so this has to be on test. And we have two samples. We have core 1 sample and core 2 sample. So we want to do number 4. Number 4 is called a 2-sample t-test, and that's what we want to do. So you can go down to 4, press enter. Here's what it looks like. We have input and we have data, input data, and it should have L1 and L2. So before you go and change anything, make sure this should line up automatically. If not, you can always change your L. If this was, say, L4, you can just change it by pressing second and then this 1 button, and that would change it to L1. Remember, to get to the blue buttons, you just have to press the blue button first. The frequencies should both be 1, and please notice, this is the test we're running. We're running a not equals to test. So that has to be on there. So you go down, you can press enter. Pressing enter will definitely put the little black box on there. The pooled for us right now will always be no. It doesn't matter the color, and then you're going to scroll down to calculate. Once you get to calculate, you're going to press enter. You're going to see a lot of things come up, but what we're going to be writing down is our X bar 1, our X bar 2, our T, and our P value. So look for those on your calculator. Here I see X bar 1, here I see X bar 2. I have my T and my P. So take a moment and please write those down. I am going to round to the nearest hundredth right here. This was in the calculator for my T. This was negative 0.235. So I'm just going to round the 3 up to the 4. Same for my P value. I'm going to put 0.815. So I'm going to round to 0.82. Now, for this course, we are not going to look, actually for this video, we're not going to look at the T. We're really just going to take our P value and compare it. But before we do that, I just want you to see, here's the mean of core 1 and here's the mean of core 2. So it's pretty interesting because they are different, but they're not different. They're not very different. They're not off by a lot. They're very close in number. So I'm wondering what we're going to come out, whether we're going to say that they're equal or not equal. And that's why we use statistics. Is this close enough to say that they're the same, or is this different enough to say that they are different? So let's now compare our p-value, our 0.82, to our alpha of 0.05. It's always going to be 0.05 for this video and for my class. We're going to compare it. 0.82 is definitely greater than. So if our p-value is greater than, just like what we did for our chi-square test, then that means that we are going to be rejecting HO because it is going to be a pretty, sorry, not reject. If your p-value is high, we do not reject HO. So I'm going to write that for you. Greater than, we do not reject. Just in case you don't have your chi-square, this is the same type of conclusions. Less than, we reject. So there we go. So if you want to write that little note, we are going to be stating a couple other conclusions here. So let's write our conclusion. And this is how you should do it for your IA. This will help you if you decide to run a t-test or any other tests. This little setup will help you. Of course, you should input more information than this, but it does get you started. So first, we have to state the means in a complete sentence. So we have to go up here and say the mean score of core 1 is a 66.2. And the mean score of core 2 is a 67.5. It's always nice to restate that in words. All right, state whether the p-value was greater than or less than alpha. So let's write that out in a complete sentence too. The p-value of 0.82 is greater than the alpha of 0.05. You can put 0.050 if you want. So now that we know that it's greater than, we are not going to do not reject HO. Since we do not reject HO, we have to rewrite either the HO or the HA. So we do not reject HO. So we're going to go back here. We are not going to reject this one right here. So since we are not going to reject this one, what does that mean? That means that they were equal, they were the same. So what did he want to do? He wants to find out if there is any difference. So was there? No, there were no difference. So since we reject HO, I'm going to put there is evidence. I always like that. That there is no difference between the mean scores of Dr. W's for 1 and for 2 classes. Yay! Okay, so now that we carried out a whole entire test together, there is another example here, and it is a one-tailed test right here. So I would like you to read through the example, and what we're going to do, I kind of filled in a little bit of the information. So let's read through the example. An oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. 10 scooters were filled with 1 liter of normal fuel, and 10 are filled with 1 liter of new. The distances in kilometers traveled on the 1 liter by each scooter are as follows. So here's the original fuel. 1 liter is used. They filled it up with 1. They see how far can that original fuel go. Then they made this new fuel, and they're like, we wonder if it's going to go farther with this new fuel that we make. So let's state what x1, the mean of the original fuel. Let's write down what x bar 1 and x bar 2 represent. And I already did that for you, so if you would like to pause, you can write these down. X bar 1 is the mean distance traveled with the original. So this is L1, which makes it x1. And L2, x2 is the mean distance traveled with the new fuel. All right. Now, this is called a one-tailed test because we're making a decision. We want to know, is the travel fuel here, is our mean with the original fuel going to take us a less distance than the one traveled with the new fuel? I know up here it says it wants to increase the distance, but you have to be careful when reading these problems. You have to understand what the problem is asking. It's asking, here we have the original. So the original, if we want to increase the distance, the original is actually going to travel less than the new one. And I just made a mistake there because you're saying, Dr. Mears, this one's always supposed to be equal. And yes, I jumped to the conclusion. My bad. My bad. I was getting nervous because I want to help you understand that our original is going to travel less distance than our new. So I was getting all nervous. I wanted to make sure that you understood this point, and I wrote it in the null. So remember, the null is always the equals one. That is always the equals. I just made the mistake I didn't want you to do. Okay, so this is always the one with the equal sign. For our alternative, we want to make sure the original travels less distance than the new. Hopefully I didn't confuse you too much. If you're paying attention, hopefully you stopped the video, was like, Dr. Mears, wait a minute. All right, number 2, let's calculate the test statistics. So let's enter our data. So put data L1 and L2, please, into your calculator. And after you put your L1 and L2 into your calculator, we are going to flip the page so that we can actually run the test. So let's go through, run the test. Now just be careful because here it says less than. So this is all determinant upon what we want. We want U1 to be less than U2. So be careful to select less than. You may need to press like your down arrow or your enter to actually get down to the next one. Don't forget you are going to have to press enter on here to make sure that the black box stays on this one. Not pooled, and then you're going to press calculate. Your numbers on your graphing calculator should be as follows. X bar 1, the mean of the original is 42.4 kilometers. The mean of the second of the new is 48.3 kilometers. Your T is negative 2.83, and your P, I went to the third decimal place because it is so small. We're going to be comparing that to our 0.05, and you're right, it is less than. Less than P, low p-value, reject HO. Low, reject HO. All right, let's write our conclusion. The mean distance traveled on 1 liter by the original fuel is 42.4 kilometers. The mean distance traveled on 1 liter with the new fuel is 48.3. So really, statistically, we're going to be seeing, is this significantly lower enough to say that the new fuel actually helps us travel more? The p-value of 0.005 is less than the alpha, reject HO. Here's our nice conclusion. The mean distance traveled on 1 liter by the original fuel is less than the distance traveled by the new fuel. The company developed a new fuel that increased the distance traveled on 1 liter. And so this is where I don't want you to get really confused, and that's why I kind of messed up a little bit with my null hypothesis. Because it is less than, because the original is less than the new, that means that the new actually took us further, thus increasing this distance. All right, this has been Dr. Mears. Little rough on the HOHA. Hopefully you stuck with me, and hopefully this helped you to understand the overall t-test. There are more concepts in this t-test in more detail. However, this is just an overview of how to run the t-test. I know for those of you in college taking this as a statistics course, you have many checks that you had to go through along the way that we did not do here. So I will have a more detailed video coming up in the future, but for now, this has been the overview. Hopefully it helped. Thank you.